If you put Betelgeuse where the Sun is, it would extend to Jupiter's orbit, a monster that is totally unsteady and about to explode. It is among the most prominent sources of radio energy in the entire universe, providing more energy than Betelgeuse or even a billion suns. Betelgeuse is a red supergiant star. Assuming you placed it where the Sun is, it would reach the orbit of Jupiter, monstrous, completely unpredictable, and with the potential for explosion. When we consider stars, we most likely imagine small glowing things in the night sky, basically looking like this, yet to see them from Earth's surface, stars are a completely different thing. In fact, one of the most prominent stars, Betelgeuse, is a lot bigger than the Sun. For many years, this star has confused scientists. However, something even more upsetting has been happening. Astronomers and others who know Betelgeuse extremely well, educated individuals, are concerned. Join us in this video as we investigate the amazing information about Betelgeuse, its impending obliteration as predicted by the James Webb Space Telescope, and how this new development could affect both our lives and the universe. As explained by physicist Michio Kaku, Betelgeuse is a massive marvel, a huge star that has interested cosmologists for a long time. A Greek astronomer named Antonius was the first to discover it. This star is so giant that it can be seen in the night sky from Earth, particularly during winter. If you're interested in cosmology, you've probably heard of or seen this star. The orange-reddish star can be seen in the upper left shoulder of the constellation Orion. So, you see, this star is ancient, and quite possibly one of the most brilliant stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay the same, it fluctuates. This change is one of the great properties of the star, but it isn't the only one. Let's investigate some of Betelgeuse's specific properties. The majority of the stars you see far away from Earth in the night sky are distant. The nearest star is 4.2 light-years away from Earth. In case you don't know how the concept of light-years conveys distance, picture it this way: consider moving at the speed of light for a whole year. It has been demonstrated that light covers a distance of 186,000 miles per second. Thus, the distance light can cover in a year is comparable to 1 light-year. If you crunch the numbers, you'll get billions of miles. So when we say the closest star is 4.2 light-years away, it means it is billions of miles from Earth. Now think about this: some stars are much farther away, and Betelgeuse is one of them. Betelgeuse is located approximately 600 light-years from Earth. So, if you somehow manage to travel to it at the speed of light, it would still take 600 years. We cannot move that fast, not even in our fastest space rockets. Even so, this star still shines in our sky with such brilliance. If you're curious about how Betelgeuse is so bright despite its distance, that's due to its unique qualities, like size. Additionally, Betelgeuse's luminosity is diverse, estimated to be somewhere around 1,000 times larger in diameter than our Sun. Tragically, it appears as a disk in space when using modern telescopes. While various stars appear as small points of light, this is believed to be a consequence of the reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equivalent to 2 times 10 cubed kilogram. Scientists can't determine the specific mass of Betelgeuse since there are no planetary bodies orbiting around it to compare with, and of course, we can't measure it directly from Earth. However, this still makes Betelgeuse at least 12 times greater in brightness than our Sun. Betelgeuse varies between magnitude +0 and +1.6. In simpler terms, Betelgeuse is many times more luminous than our Sun and earned the nickname Red Giant for good reason. However, the brightness of Betelgeuse doesn't stay constant, it fluctuates. This change is due to its pulsations. As Betelgeuse expands, it becomes brighter; when it contracts, it dims. This cycle can last from 10 to 100 days, or even significantly longer. A unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field here is far stronger than on the Sun's typical surface. However, the downside is that these spots hinder the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has so many of these spots compared to our Sun helps explain why it is cooler, despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and significantly more numerous. To provide perspective, some spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is 10 times more powerful than that of the Sun. This field is the reason that, when seen through a telescope, the gases on the outer layer of Betelgeuse appear to form arcs or curves. Betelgeuse has a surface temperature of around 3,500 K. This low temperature contributes to the relatively weak energy radiated by the star and its distinctive red hue. Betelgeuse is a red star, but it wasn't always. About 10 million years ago, it was yellowish, much like our Sun. Over time, the color began changing to orange-red, and then, around 100,000 years ago, it gradually transitioned into the red star we know today. This fact has led scientists to believe the star is maturing. Betelgeuse produces as much as 100,000 times more energy than the Sun. If it weren't so far away, it would challenge the Sun in dominance over our sky. The fact that Betelgeuse, which is 600 light-years away, can still be seen with the unaided eye at night is quite striking. Our Sun is only 8.3 light-minutes from Earth, which is why it's so powerful. If Betelgeuse were just slightly closer, we would be able to see it during the daytime as well. But if it took the place of the Sun, it would consume or displace Earth and the other 4 inner planets because of its gigantic size. Even if it matched the Sun in position, it would still emit far more radiation. Betelgeuse, also known as Betelgeuse, is this enormous star situated in the Orion constellation, approximately 600 light-years from Earth. Its gigantic size is one of its most striking features. It is multiple times greater than our Sun in radius and could easily envelop Jupiter's orbit if placed at the center of our solar system. This legendary size allows Betelgeuse to appear as a disk rather than a point of light when viewed through powerful telescopes, unlike most other stars. Despite its size, Betelgeuse is not the most massive star. Its mass ranges from about 12 to 19 times that of the Sun. This variation is due to the difficulty in measuring the mass of stars without companion objects for gravitational reference. Still, even at its lower estimated mass, Betelgeuse remains a colossal celestial body. The brightness of Betelgeuse is another key characteristic. It fluctuates constantly over time, ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is approximately 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be up to 1,000 times more brilliant than our Sun. These pulsations, the sporadic expansion and contraction, are caused by internal processes. When Betelgeuse expands, it becomes brighter. This gives it a distinct red color typical of red giants. But despite its relatively low surface temperature, Betelgeuse's sheer size allows it to emit an extraordinary amount of energy, estimated at up to 100,000 times more than our Sun. Its immense luminosity is one of the reasons it is easily visible from Earth, even at a distance of approximately 600 light-years. Interestingly, Betelgeuse is not the most massive star in the universe. In fact, there are other stars with greater mass, such as the Wolf-Rayet stars or the hypergiant Eta Carinae. However, Betelgeuse's significance lies in its current life stage. It is believed to be approaching the end of its stellar life cycle, meaning it is likely to go supernova at some point in the, astronomically, near future. What does this mean? A supernova is one of the most powerful events in the universe. When Betelgeuse eventually explodes, it could briefly shine as bright as the full moon, possibly even visible in the daytime, and remain visible for weeks or months before fading. Despite this, scientists reassure us that Earth will not be harmed. At 600 light-years away, the explosion would be spectacular but not dangerous to our planet. There was considerable excitement among astronomers in late 2019 and early 2020 when Betelgeuse dimmed significantly for several months, something that hadn't been observed before at such a dramatic scale. This event triggered widespread speculation that the star might be about to explode. Later, it was revealed that this dimming was likely due to a massive ejection of material from its surface, forming a dust cloud that temporarily blocked some of its light. Today, Betelgeuse continues to be a subject of intense study, especially using advanced instruments like the James Webb Space Telescope, which allows astronomers to observe the star in unprecedented detail. Scientists now monitor Betelgeuse closely, trying to better understand its internal dynamics, magnetic fields, and signs of instability that may signal its imminent transformation into a supernova. The fate of Betelgeuse is not just an isolated cosmic curiosity, it represents a window into the life and death of stars, including what may someday happen to stars like our own Sun, although on a much longer timeline. Whether its final explosion happens tomorrow or 100,000 years from now, one thing is certain. Betelgeuse is a spectacular example of nature's power, beauty, and unpredictability. Nearing the end of their life cycles, similar to that of other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun combining heavier components. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It exhibits dark magnetic locations on its surface where the field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the star's surface. Despite these cooler spots, Betelgeuse remains a massive, vigorous star, but it will eventually meet its end. Betelgeuse is a stunning supernova in the making, an enormous star nearing the end of its life. Its possible fate will be a dramatic one. When it runs out of fuel, it will go through a severe process of fusion, turning heavier elements like carbon and helium. This will cause the star to expand to possibly much greater sizes, making it one of the largest stars in the night sky before it dies in a catastrophic blast, a cosmic explosion that marks the death of a massive star. The power of a supernova is strong enough to briefly surpass the brightness of an entire galaxy. This phenomenon could potentially send shockwaves through space, and it is possible Betelgeuse will undergo such an explosive end very soon. While this fate is not immediate, scientists are carefully studying it, hoping to learn more about the future of stars and the evolution of the universe. As Betelgeuse nears the end of its stellar life, astronomers are paying close attention to its behavior. It is expected to eventually explode like a supernova, an event that will result in the ejection of its outermost layers into space. Beneath these layers, the core could collapse into a neutron star or, depending on its mass, further into a black hole. A supernova is a cataclysmic event in a star's life cycle, signaling the final stages of its evolution. Betelgeuse's death could result in a supernova visible from Earth without the aid of a telescope due to its enormous brightness and relative proximity. This explosion would release vast amounts of energy and forge heavy elements like iron and nickel, which are essential to the creation of planets and other celestial bodies. These elements would be scattered throughout the cosmos, enriching the interstellar medium and contributing to the formation of new generations of stars and planets. Interestingly, researchers have identified strange fluctuations in Betelgeuse's brightness in recent years, leading to speculation that the star could be on the verge of a supernova. However, despite these variations, it's difficult to determine precisely when the star will explode. Some research suggests that Betelgeuse might explode within a few 100,000 years, a brief span in the life of the universe but still far off by human standards. The James Webb Space Telescope, JWST, has provided fresh perspectives on the star. Its infrared capabilities allow researchers to investigate the star's outer layers and magnetic fields in unprecedented detail. The JWST findings have helped confirm the star's ongoing changes, including its irregular brightness and potential instability. These observations offer valuable information about the processes leading up to a star's death, providing a better understanding of stellar evolution. Betelgeuse's death will have profound repercussions for the universe. The supernova shockwave could have the potential to trigger the formation of new stars in the surrounding region, advancing the cycle of stellar birth and death. Additionally, the elements produced by the explosion will spread throughout space, enhancing the material that forms new worlds. In the grand scheme of cosmic evolution, the death of Betelgeuse will not only mark the end of one of the most massive stars we can observe, but also pave the way for the next generation of celestial objects. Despite the fact that we won't witness the star's final moments ourselves, the study of Betelgeuse provides valuable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on this star helps astronomers better understand the processes that govern stellar birth, life, and death. It offers a glimpse into the fate of other stars with similar characteristics. In the future, scientists hope to continue studying Betelgeuse with the help of advanced technologies and space observatories. The data gathered from the star will continue to shape our understanding of astrophysics, helping us unlock the mysteries of how stars die and what their deaths mean for the entire universe. Betelgeuse, as a massive and dynamic star, is a key piece of the cosmic puzzle. Its eventual demise will be one of the most fascinating events in the life of our galaxy. While Betelgeuse's death is inevitable, it's critical to remember that the universe is constantly changing and evolving. New stars are being born all the time, and the energy released by supernovae like Betelgeuse's ensures that the cycle of life and death in the cosmos continues. The legacy of Betelgeuse will live on, not only in the elements it produces, but also in the knowledge it has provided to generations of astronomers and stargazers. By studying stars like Betelgeuse, we continue to unravel the mysteries of our universe, gaining a deeper understanding of the forces at work in the cosmos and our place within it. As we learn from these celestial giants, we are reminded of the vastness and complexity of space and the awe-inspiring processes that shape the universe we call home. As Betelgeuse continues its slow march toward its final act, scientists across the globe remain vigilant, monitoring even the subtlest shifts in brightness and radiation. Each data point collected from this colossal star could unlock answers to some of the universe's most fundamental questions. How do stars die? What triggers a supernova? What happens in the moments just before and after a massive stellar collapse? The anticipation of Betelgeuse's explosion has also sparked public fascination. Amateur astronomers and space enthusiasts have turned their telescopes toward Orion's shoulder, where Betelgeuse shines like a ruby, hoping to witness history. Although the chances of the supernova occurring within our lifetimes remain slim, the very idea of seeing such a spectacle excites both scientists and dreamers alike. Should Betelgeuse explode, it will be a once-in-a-civilization event. The night sky will change dramatically, with a new bright object potentially visible even in daylight for weeks or months. Ancient civilizations may have marked the deaths of stars with myths and legends. Today, we interpret them through science, but the sense of wonder remains the same. The ripple effects of Betelgeuse's death will go far beyond visual spectacle. As shockwaves travel through the interstellar medium, they can trigger the collapse of nearby gas clouds, giving birth to new stars. This illustrates the cyclical nature of the cosmos, how the end of one celestial life can catalyze the beginning of many others. It is poetic, in a way, that from death comes rebirth, and from destruction, creation. In labs and observatories, researchers simulate supernova conditions, attempting to recreate what Betelgeuse might experience in its final moments. These models help improve our understanding of nuclear physics, particle behavior, and even the origins of life, since the elements essential to our existence were forged in the cores of stars like Betelgeuse. In a universe governed by chaos, decay, and renewal, Betelgeuse stands as a luminous reminder of our connection to the stars. We are, quite literally, made of stardust, atoms forged in ancient explosions billions of years ago. The death of Betelgeuse will add to that legacy, contributing matter and energy that will eventually shape new worlds, perhaps even new forms of life. Until that moment arrives, we continue to watch, to wonder, and to learn. Betelgeuse may be nearing its end, but its story is far from over. It is a chapter in the grand narrative of the universe, a tale of time, transformation, and transcendence. And when that final explosion does come, lighting up the sky in a glorious farewell, it will remind us once more of the beauty and power of the cosmos.